the suffocating reason your lungs borrow half their oxygen from something buried 3 miles underwater. And in 2024, deep in the Labrador Sea, it stopped working. For 43 consecutive days, the ocean forgot how to breathe. Scientists logged it as an anomaly. They were wrong about what it means for you, and wrong about how close we already are. Right now, while you're watching this, the ocean is inhaling, not metaphorically. There is a mechanical, rhythmic process happening beneath every square mile of open water on this planet, a circulation system so massive it takes 1,000 years to complete a single cycle. Oceanographers call it the global conveyor belt. You learned about it in school. What they never taught you is that this entire belt runs on a single, fragile mechanism. One process, one threshold. And for the first time in recorded history, instruments buried in the North Atlantic caught that process stuttering to a halt. Your next breath depends on what happened next. Here's what the ocean actually does. Every winter, freezing surface water in the North Atlantic gets dense with cold and heavy with salt. It sinks, fast, 2 miles down in under a week. And when it drops, it pulls warm, tropical water north behind it, the same way a bathtub drain pulls everything toward the center. That sinking motion is the ocean's inhale. The slow rising of deep water elsewhere is the exhale. Every oxygen molecule your lungs just used passed through that cycle at some point. Now here's what scientists found in March 2024. Research vessels operating in the Labrador Sea, one of the 2 critical sinking zones on Earth, recorded something that stopped the entire team cold. The water wasn't sinking, not slowing, not reduced, stopped completely. The conveyor belt's engine had stalled. And nobody on the surface had any idea. The sky looked fine, the sea looked calm, but 3,000 meters below where you're standing, the ocean had simply held its breath. You might be thinking, a short pause, systems recover, this is alarmist. And that exact instinct is what makes this dangerous, because the ocean has done this before. 12,000 years ago, a glacial lake in North America, Lake Agassiz, drained catastrophically into the North Atlantic in a matter of weeks. The freshwater influx shut down the same sinking mechanism. What followed was a cold snap so severe and so sudden that temperatures across Europe dropped 8 degrees Celsius in less than a decade. Not a century, a decade. Frozen mammoths have been recovered with undigested grass still in their stomachs. The cold arrived faster than digestion. That's the pattern the ocean runs on. It doesn't warn you, it just stops. Here's what scientists just published, and why the 2024 stall is different from everything we've seen before. The Labrador Sea event wasn't caused by glacial meltwater. There was no catastrophic flood, no single dramatic moment. The surface water had simply lost enough density that it could no longer sink. Not from ice, from warmth. The top layer of the North Atlantic has been slowly freshening and lightening for 3 decades as Greenland's ice sheet quietly hemorrhages meltwater, not in one dramatic collapse, but in a slow, invisible dilution. Year after year, glacier calving by glacier calving. Researchers from the Alfred Wegener Institute ran the 2024 data through their deep circulation models and found something none of them had anticipated. The threshold. The precise salinity number below which North Atlantic surface water can no longer achieve the density required to sink. And during those 43 days in 2024, the Labrador monitoring sites recorded readings that crossed it. Not approached it, crossed it. The system didn't stall because of a single disaster. It stalled because the baseline had shifted, quietly, incrementally, until one winter the engine simply didn't turn over. What makes this extraordinary is the feedback it triggers. When deep water stops forming, the ocean can no longer pull carbon dioxide from the surface. The atmosphere retains more heat, more ice melts. The surface freshens further. The engine finds it even harder to restart. Scientists have a name for this kind of self-reinforcing loop: a tipping cascade. You've heard the phrase tipping point before. A cascade is what happens after you've already tipped. The conveyor belt doesn't just produce your oxygen, it regulates the temperature of every coastline across the northern hemisphere. London sits at the same latitude as Calgary. It stays mild because the ocean carries heat there constantly. Shut the conveyor down and northwestern Europe doesn't gradually cool, it snaps. Agricultural calendars collapse within a generation. Fish populations that anchor entire national economies migrate or vanish entirely. Here's what keeps oceanographers awake. The 43-day stall in 2024 did restart. The winter deepened, the water cooled just enough to sink again, and the monitoring teams exhaled. But the baseline didn't reset. The salinity levels that enabled the stall are still there, slightly worse than last year. The threshold was crossed once. Crossing it a second time is now easier than the first. The question no model can answer yet is whether there's a restart threshold too, a salinity floor so low that even a brutal North Atlantic winter can no longer force the surface water deep enough to matter. If that number exists, and the data strongly suggests it does, then somewhere in the ocean's future is a winter that looks completely ordinary. Cold air, dark water, routine, and the conveyor simply doesn't come back. Nobody will know it was the last breath until long after it was gone.